So while we've talked a little bit about precipitation before, now we want to talk about or take a look at climate types, which really take into account when precipitation occurs, as well as what the interplay of precipitation with temperature is. And so let me select some stuff here. So you can see here the timing of precipitation, and we've seen that the timing of precipitation actually has a great deal of effect on the total forage that's produced in any range system. We said that 20 inches of rainfall is really an interesting cutoff point for us, that that underneath that level of precipitation we have really drastic responses in terms of forage to the precipitation amount, all things being equal. Above 20 inches of precipitation, we have other factors come into play. So soil factors, topographic factors, and so forth. So we have ways to think about precipitation. Number one, the timing. Number two, the total amount. The annual average. Temperature also comes into play in terms of another factor besides precipitation that are factors that affect forage. And we've been saying, okay, so while 20 inches of rainfall is that's an interesting rule that we can hang our hat on, we say all things being equal, because we know that temperature is going to have an effect on whether or not that precipitation is useful to the plant, storable by the soil, or not. Okay, so we have sort of these factors, and what happens is that a climate type gives us a way to talk about all those factors at once. So we're going to talk about some of the U.S. Climate types. I'm going to show you an example, and then you can work through the other examples on your own as you go through the slides themselves. We're going to be really broad. About the climate types. So here you see a big, huge breakup and a very, very broad generalization of climate types in the U.S., starting on the west coast with the Pacific, moving over to the Great Basin, southwestern plains type, eastern type. And if you've lived in any of these areas or regions, you know that we are being really broad, and that's okay to a certain extent. And we have Florida has its own sort of type of climate itself. So that's how we're going to break it up. That's how we're going to think about it when we think about climate types in this class. These graphs are really helpful to understand, to give us a single picture of what's happening with precipitation over a year. So you can see the first thing that this should be kind of striking to you, and what you'll see is you've got a city and you've got a type, right? So when we say Great Basin type, what are we talking about? When we say Pacific type, what does that denote? What does that make us think of? So for Pacific type, here in the upper left-hand corner, we've got these huge amounts of precipitation, and again, these are on monthly time scales. So starting in January, ending in December. On the right hand, you've got the millimeters. On the left hand, you've got inches. And so you can see that Olympia, Washington has a huge amount of precipitation happening in the winter months, right? Even though we've broken this up and put it in a sort of a linear perspective, really, for a place to get 6 inches of rainfall or 7 inches of rainfall in a month is quite a bit, at least in the scale of where we're at in Wyoming. So you can see that the winter month is very, very high in terms of precipitation. The summer months is very, very low, less than an inch for 2 or 3 months, very little precipitation. And that typifies our Pacific type climate, or type precipitation in the precipitation in the Pacific type climate. As we move over to the Great Basin, so we're here, you can see that the scale of precipitation is way less, right? So we're getting at maximum about 1 inch of rainfall per month in the highest months of the year. As we move to a different version of Great Basin here, the rainfall goes up a little bit. Okay, a little bit. It changes also in terms of when we see these peaks, right? So just when we're about to say, oh, this is the Great Basin climate. Well, the only thing we can conclude from this is that the Great Basin climate has a pretty substantially low amount of precipitation. There's varying peaks. So those three peaks that I just drew arrows to versus this peak here and a winter peak, those are at different times, right? And they're not the exact same time as what we see in Salt Lake City. Okay, so we learned some things about that. We have Southwestern as well, and in this particular Tucson example of the Southwest, we've got a peak that happens in later summer here. Still not substantially high, only 2 inches. Okay. In the plains type climate, these two right here, we see Bismarck, North Dakota as a really far north version of this, and Colorado Springs, Colorado as a very far western version of this. The take-home message here is that you've got a peak of precipitation happening excuse me, fairly consistently through pardon me, throughout the summer. This is typical of plains climates that or plains precipitation patterns is that you have consistent precipitation, typically rainfall, almost always rainfall, in the summer months. This is really important because this is conducive to grasses, particularly warm season grasses. The higher this goes and the more warm the month is, the more that will select those kinds of grasses for those areas. The eastern climate, what you can see there is again a consistent high rainfall pattern across the or high precipitation pattern across the months, and that's really key, especially since the east is pretty much tree growing territory. Trees require a high amount of precipitation, and therefore you see that in the climate that is built for that. Right, those trees are built for that kind of climate. In the Florida type climate, you see just a major peak of precipitation happening in those really warm summer months, very very hot summer months. So this gives us a snapshot of what these particular climates are going to show to us or offer us, or at least dictate to the plants what kind of growth we can expect from those. So what we're going to do throughout this, and I'm not going to go through every single one of these, I just want to point out the sort of the flow of how of what we're going to talk about with each one of these climates. So in each one of these climates, we're going to give you an area. So here we're talking about the Pacific coast of California, Oregon, Washington. You can read those here. We're going to talk a little bit about the dryness or wetness. When are we going to see precipitation? What kind of percentages we can estimate in a particular region. We saw in the Pacific climate that you have a pretty severe lack of precipitation happening in the summer. So some of those messages that we saw when we were looking at the graphs, you'll see again here. I'm going to move on from this and go to some different slides towards the end of this, but you should probably pause this and take a look at the other graphs, the other climate types, and see what sorts of information go with each one of the climate types. You need to understand that those climate types are going to be very important when we think about what kinds of rangelands we have across the world and in the United States. The climate and the precipitation and temperature, which are two aspects of climate, have a great deal to do with what kind of plants are in any given rangeland. Okay, so the next little piece we're going to take a look at is some of the other physical characteristics. And remember, we're being pretty broad now in terms of what kinds of characteristics do we find on the rangeland that are influential to what happens on the rangeland, what kind of forage we can grow, what kind of wildlife or ecosystem services are available in that particular rangeland. One of them is topography, and topography is another. We're taking each one of these factors and we're pointing out the importance of each one of these factors. You can't ever remove one factor from another, even though we try to do that to sort of give you an example of why a particular factor is important. But you can't do it because you have those factors always existing in with the other factors. So we can say topography is a thing, right? Topography is a landscape, is an elevation factor that's going to control what kinds of biology you're going to have in any given rangeland. One of the things we learn about topography, one of the very first things you need to know about topography and its relation to rangelands in the United States, is that generally speaking, when you move from the eastern United States into the western United States, you go from low elevation to higher elevation. That's the lay of the land in a real literal sense, and that affects the kind of climates we have out here, the kind of soils, and also the kind of biology that we find on these landscapes, especially that are in the West. We have some rules for that, and one of those are what you see here, this thing called Hopkins' Law, and that says that when you go up in elevation, it's as if you've gone north you've traveled north in latitude, and so we know that when you go to a northern climate, typically you're going to find a cooler climate, and that's one of the things that is sort of intuitive about existing in say the United States. You go south, you go to a warmer climate, and so what this law states, it just is the impact of moving up in elevation, even though you're not traveling any distances. If you go up in elevation, you're going to start changing what the weather pattern is like, what the precipitation patterns are like, what the temperature regime looks like. So that's something we have to understand about topography, is that it has a lot of effects. The first one of which is the fact that it has an effect on the climate, such that it's as if you moved north. Another piece of topography is what we call aspect. So if topography is generally speaking the lay of the land, the rolling hills of the land, or the flatness of the land, the steepness of the land, those sorts of things, aspect is a part of that. Aspect, as it were, is an aspect of that. And really what aspect tells you or shows you, lets you get your head around, is that the direction that any slope, if you have a slope, the direction that slope faces is very important to, again, the production and the kind of soils that form there, the kind of biology that exists there, the kind of plant life that's able to live on those kinds of range. Now, we're in North America, and what we experience in everyday life is that if you're on a south-facing slope, it tends to be warmer, and usually where we are, it tends to be more arid type plants. If you are on a northern slope, if you're looking at a northern slope or find yourself on the northern slope, typically the soils have been wetter for longer in the year. It's cooler. You have more cool season plants. You have a sort of an effect of a protracted growing season, less sunlight, and so forth. So we see that aspect really can make a difference. It makes a difference in terms of the ability to collect solar energy. It makes a difference in the evaporation potential of that soil, whether or not it's got a lot of solar energy on it or not a lot of solar energy on it. The other thing that aspect has a effect on is the wind that aspect, the effective aspect plays into, is winds, different kinds of winds. And so if you're on the side of a slope that the wind isn't hitting, you're going to have less potential for evaporation, wind erosion, things like that to happen off of that soil. So the aspect that sloping of the direction of the slope of the soil, and we've got a picture right here. And so what you can see is really lush growth on this side of the soil. Okay, probably a northerly facing, although it may not be exactly north facing, the northerly facing side of the slope, as opposed to this side. Okay, over here, you can see it even looks a little more arid, a little more scrubby, less dense in terms of the plant composition there. And so again, a real vivid display of the nature of aspect. Now again, we try to separate this out. We can't separate it out exactly because there might be some soil differences from one side to another. We can't tell from this picture, but that might be another factor that's controlling what happens here. So again, we try to pull things out, but we can't pull it out exclusively out of the ecosystem because there's other effects of ecosystem factors that are happening to control or to contribute to different kinds of species existing in a place. We talked about slope earlier, and the steepness of a slope has a great deal to do with it. Excuse me. Its ability to be used as rangeland. So actually, like literally, can livestock walk on that slope? If they can't, then they're not going to be able to consume anything that's growing on that slope. Also, if a slope is very, very steep, you're going to have less soil depth on that slope, generally speaking. So the plants that live there are not going to have the rooting depth that something in a gently sloping plain might have over time. The depth of the soil that might be created there. So we have some aspects where topography itself is a player, but it's a player in that there's all these other reasons why topography is affecting the biology. So we think about aspect, and we think about how steep a slope is as a controlling factor in terms of animals, in terms of soil depth, and therefore plant life. And soil depth is another factor of soil depth is the ability for that soil to store water over a longer period of time. The more shallow the soil is, any exposure to sunlight or wind is going to drive a lot of that moisture off of that soil, and that soil is not going to act as a reservoir of soil or a soil water holder. If we have a deeper soil, we have more space for that water to move down into the soil and to stay there, even though we might have some wind, we might have some solar heating of the top of that soil that causes evaporation to happen. We're going to have some of that water that's out of the zone of evaporation in the soil, and that's really a key factor.